My name is Dr. Lee Farrow. I'm a professor of history at Auburn University at Montgomery in Montgomery, Alabama. I'm going to be going through this presentation and giving you some background on the history of the Brooklyn Bridge and why we consider it an engineering marvel of the 19th century. There was, a need for a bridge, but of course, the only kind of bridge that could span that width of a river would be a suspension bridge. But people were nervous about a suspension bridge, and there had been some suspension bridges that had collapsed or had other problems, and so um, there was divided opinion on whether or not a suspension bridge was a safe way to go. But there was one man who had some good experience with this, and his name was John Roebling. So you can see from the slide here that he had built the Niagara Falls Suspension Bridge in the 1850s. He had also built a bridge over the Ohio River. So he was one of the few engineers in America who had learned how to do this and who was actively designing this particular type of bridge. And so in 1867, something called the New York Bridge Company uh, was formed, and John Roebling was appointed the engineer for the bridge after presenting his design for a suspension bridge over the East River. And this sketch to the left is part of his overall design plan for the Brooklyn Bridge. So this was in 1867. So who was John Roebling? John Roebling was a German-born American civil engineer who was a real pioneer in the design of suspension bridges. And as I've said, among his accomplishments were the two bridges that I have pictured here on the right. He recognized the need for a bridge across the East River probably a decade before anybody else, because he had actually begun designing a plan for that bridge in 1857. But at this time, there was still too much concern over the building of a suspension bridge. And we should also think about the people who ran ferries, who made their careers running ferries. They were obviously opposed to the building of this bridge because it would deprive them of their livelihood. So there was also that. Finally, I just want to mention, because I think that this is interesting. Well, there's one other thing. I guess there was also concern about how a bridge might interfere with the river's uh, merchant transportation. So they were concerned that a bridge would not be high enough or that the towers would impede the flow of traffic on the river. So they were concerned that ships would not be able to get under a bridge or that there might be too much traffic because of these extra pediments that would be in the water, in the way of the easy flow of traffic in the water. So there were a number of reasons why people objected to this bridge. And then there's one other thing that I wanted to mention that I just thought was very interesting. There was this fierce competition between Brooklyn and New York. So of course, New York had originated first, and then Brooklyn had grown as kind of a suburb of New York. And it really wanted to establish itself as its own place. Earlier in the century, in the 1830s, there had been a move on the part of Brooklyn to become its own city, and New York had actually tried to stop that. So there was a lot of competition between Brooklyn and New York. And so while there were needs for a bridge, there were some in Brooklyn who did not want to connect the two cities because they thought it would just further the absorption of Brooklyn into New York. And later in the century, I actually found a really fantastic quote in which the city officials in Brooklyn said that they were tired of being the tail on the New York kite. So they were tired of always being kind of an afterthought. So this competition between them was something that probably factored into some of the early discussions about whether or not a bridge was a good option too. But by 1867, circumstances made the question of a bridge over the East River important again. That winter had been exceptionally cold, and so ferry service had been regularly interrupted or delayed. And of course, this posed a significant problem for people who relied on ferry traffic or ferry for transportation to work. So finally, the New York legislature approved the idea of a bridge. Now, over the next 2 years, while Roebling waited for federal approval and appropriations for construction costs, he began to refine his design, and he also trained his son, whose name was Colonel Washington Roebling, as his chief assistant. Now, the younger Roebling had a decade of bridge building experience of his own at this point, and he had even spent a year in Europe studying the new technique of building underwater foundations by means of pneumatic caissons. And that would be the next slide now. So this particular part of the plan was critical because the towers of the Brooklyn Bridge would have to have their bases so far beneath the river that other methods of support would not work. Everything seemed to be moving in the right direction when tragedy struck. So in July of 1869, while making a final inspection upon the site or of the site upon which the construction would soon begin, Roebling was injured when, if I read it correctly, he was standing on a piling and a ferry bumped into it and his foot got crushed. Now, that's a bad injury, but it should not be life-threatening. However, several of his toes were crushed and had to be amputated. And he was, laid up in bed for a little while. But no one thought that it would turn into a terminal situation. But within a couple of weeks, he died as a result of tetanus. So that injury got infected and he died of tetanus. Now, his death was a devastating blow to the project, and many people had had faith in him only because he'd had so much experience with these other bridges. And so now this really threw into question again whether or not it was safe to build that suspension bridge. Finally, though, after some consideration, city officials decided to appoint his son, Colonel Washington Roebling, as the chief engineer. Now, Roebling, the younger Roebling, had a very difficult task ahead of him, and much of it centered on the building, submerging, and use of these caissons to build the bridge's underwater piers. Now, a caisson is essentially a box that is submerged and used as part of a foundation. And it can also allow workers to dig deeper into the mud until they hit some kind of bedrock upon which that tower will stand. Now, caissons had been used for many centuries. So Roman and medieval engineers had used basic versions of caissons when they were building underwater foundations. But for centuries, these things were used in a limited way because ultimately they were limited by man's capacity to withstand the pressure of being underwater for long periods of time, right? Because even if the workers had a means of breathing, they couldn't stay underwater very long because of the pressure. In the 19th century, however, the invention of compressed air allowed engineers to design a caisson that eliminated the problem of water getting into the caisson. So the first pressurized airlocks and pneumatic caissons were actually used as early as the 1830s. I have to admit, when I was reading about this, and this is not the first time I've read about this, I was really shocked that it was that early when they figured out how to do this. It seems like a very complicated process to me, but of course I'm not an engineer. So one prominent example of a bridge that was constructed with caisson engineering was the Eads Bridge in St. Louis, which crosses the mighty Mississippi River. Now, James Eads was one of only a handful of these engineers who was engaged in advanced bridge design during this time. And he worked on the Eads Bridge, which is named after him, in 1867, and it was finally completed in 1874. During its construction, Eads had to deal with something called caisson sickness, which was a sickness suffered by some of his men. This puzzling illness would ultimately kill 15 men working on the St. Louis Bridge and cripple a number of others as well. Now, caisson sickness is what we now refer to as the bends or decompression sickness. And it's a medical condition in which gas bubbles form in the bloodstream and tissues of a person when they move from a high pressure environment like deep water to a low pressure environment like the surface, right? Like land. Now, when Roebling took over the Brooklyn Bridge project, he was following in the footsteps of his father, but he was also following in the footsteps of James Eads. Now, the first caisson for the Brooklyn Bridge was a 3,000-ton upside down box, and it covered nearly half an acre. That just tells you how enormous it was. It took 6 tugboats to pull that caisson into place. Now, once the water was forced out by air compression, workers could go into the box, into special chambers, and start digging out the stone and sand of the riverbed from beneath the walls of the box using shovels and picks. Next slide, please. These workers became known as sand hogs. So a hog, of course, as you know, is like another name sort of for a pig. So their job was to go down into this caisson from which all the water had been pushed out, and then they had to dig along the edges, the walls, so that that caisson could keep sinking. And of course, they had to eventually dig out the floor they were standing on as well. And then that material would be taken out. And that way the caisson could keep sinking through the mud until it hit something solid enough to stop, right? So this would allow the box to sink deeper until the engineers said, okay, this is solid enough. We can stop here. Then the boxes would be filled with concrete and the towers would be built on top of them. Now, this work was obviously very dangerous. It was slow. It was very hard work. The boxes sank only an average of 3 inches per day. That's so little for so much work. And the workspace itself, of course, it was dark. It was damp. It was hot. It was loud. Imagine all of these tools being used in this small space, lots of men working, clanging tools. It also was dangerous because the elevated oxygen level created by the pressurized caissons created a very high fire risk. So this was especially true because the caissons were often lit with gas lanterns, or sometimes for very close work, they might use candles. So they had open flames in these places where there was already an elevated oxygen level. And of course, the caissons themselves were constructed of wood initially. And so they also could catch fire, even though they were underwater. They technically could catch fire. Now, the most unusual problem, of course, is the one that we've already mentioned, and that's the caisson sickness. So at the Brooklyn side of the Brooklyn Bridge, the caisson only needed to settle at 44 feet below the river's high tide level. So caisson sickness did not cause many problems on that side of the river. But on the New York side, the situation was different. And the caissons had to go almost twice as deep, which means that the workers had to work under far greater pressure for long periods of time. Now, in early 1872, one man after another fell prey to the familiar symptoms. They would get dizzy, they would get headaches, they would get nauseous and vomit, they would sweat, and they would have pain and cramps. Some of them lost consciousness. Some of them were even temporarily paralyzed. So the symptoms of this illness could be quite serious. And over 100 men were struck down during this period. Sometimes they were only sick for a couple of days, but other times they were sick for weeks at a time. And in the end, 3 men actually died as a result of caisson sickness. So the plague of caisson sickness resurrected concerns about the bridge project, and Roebling was accused of criminal negligence. So, of course, people always are looking for someone to blame, and they thought that Roebling was not doing a good enough job to protect his workers. And as a result, Roebling, who was a very responsible man by all accounts, decided that one way that he could do that is to spend more time there himself. So not only would he be working down there and overseeing things, but making sure that the conditions were safe for his men. So he started spending more time in the caissons, really worried about the conditions of the men and making sure that things were moving on time. In doing so, however, he neglected his own safety. And so that same year, he also collapsed. And though he continued to oversee the project, he was very, very ill and he was virtually bedridden. It was at this point that Roebling's wife, Emily, stepped up. So, and that's the next slide. Emily is not usually given enough credit for her role in the building of the bridge. So for many years, when anybody talked about the building of the Brooklyn Bridge, they only talked about the Roebling men. They never mentioned Emily, or they did so only in passing. When I was pulling together this presentation, I saw in a couple of different places where, it was mentioned almost as just an afterthought that Emily stepped up. She did a lot of work, because once John Roebling was dead, and now Washington Roebling is incapacitated, the bridge project would have stopped, or they would have appointed somebody else less qualified as the engineer had Emily not been there. So Emily became his spokesperson. So while Washington sat on the balcony of their home in Columbia Heights, looking through essentially binoculars at what was happening with the bridge construction, Emily fought to keep him as chief engineer, and she continued to advocate for the project and for her husband. She dealt with politicians, she spoke with other engineers, and all the people who were involved in the making of the bridge. So she was out there talking to workers and other engineers and so on, as a woman in the 1870s. This is quite unusual. She became very knowledgeable about cable construction. She learned all about the tensile strength of materials, and she also learned all about the stress and strain analysis of those materials. So even though she had not been trained the way her husband had, by the time she stepped up to this position, she had already kind of educated herself on a lot of this stuff. And so she was actually kind of serving as the chief engineer, including day-to-day supervision of the project after her husband had to take to his bed. Next slide. The final phase of the construction that posed challenges was the stringing of the cables. So once those towers were erected, somehow they had to connect those cables, right? And not surprisingly, many men were afraid of being suspended hundreds of feet above the river by only a few wires. But there was one man who had a lot of experience in this and was able to demonstrate the process and persuade other men that it was safe to join him. And this man was named Frank Farrington. Next slide. Farrington was a mechanic who had worked for John Roebling on several of his other suspension bridges. And obviously the illustration on the left is a drawing, but Farrington gave a demonstration of the ease and relative safety of the process when in August of 1876, he traveled by cable across the river on a small wooden swing. And of course, crowds and crowds of people came out to see this, and it sort of relaxed tensions about this, what seemed like a daunting and maybe impossible task. And after this, people were persuaded that it was a project that could be done, right? So to facilitate the cable spinning, a wooden catwalk was built. This was a 4-foot wide footbridge. Next slide, please. Which allowed workers to access the upper reaches of the bridge. So you can see that catwalk or that little footbridge up at the top there. Now, over a period of 6 years, workers erected cables and steel rope suspenders. They added other pieces of the bridge like trusses and braces. They installed tracks for cable cars, and they made provisions for an electric light system. Now, there were still challenges, of course. In 1878, a terrible accident occurred. A cable strand broke loose. And of course, those cables are stretched tight. So when it broke loose, it went whipping through the air. It ended up killing two men. It injured several others. And it whipped over like the streets and the housetops of part of the city. So needless to say, that scared people, and this also made people call again for Roebling to be removed as engineer. But eventually, the project was complete and set to open on May 24th, 1883. And even President Chester Arthur was present for the occasion. Next slide. There were bands, there were decorations, fireworks, there were military salutes. There was a lot of excitement, but there was still a lot of fear. So there were still people who were a little nervous about the idea of this bridge suspended by cables. Emily Roebling was the first person to cross the bridge by carriage. Next slide. Over 100,000 people walked across the bridge that first day it opened, completely without incident. But a week later, fears were still running high. And during some crossing of the bridge, apparently I read several different stories, but it sounds like a woman got her heel caught in something on the bridge and she started to scream. And people took the screaming to mean that the bridge was collapsing. And so people just started running wildly. And so it led to a stampede, and 12 people were killed and several dozen others were injured. So it would take time for the general public to really trust that this bridge was safe. But one man was ready to help Americans believe that it was. And this is a famous American sort of, folk hero, I'll say it away, right? America's Greatest Showman, P.T. Barnum. Next slide. So earlier that year, showman and circus founder P.T. Barnum had suggested marching his elephants, led by his most famous elephant, Jumbo, across the bridge in celebration of its opening. Initially, he was turned down, but after several months and, of people still feeling nervous about this bridge, the city finally decided that it was a good idea, that maybe this would persuade people that it was safe. So on May 17th, 1884, next slide, Barnum marched 21 elephants and 17 camels across the Brooklyn Bridge. And after this, when the animals made it across just fine, people started to really believe that the bridge was safe. And I just love this story because I think it's such a colorful part of the story, and probably something a lot of people did not know about the Brooklyn Bridge. So next slide, let's look at the story of the Brooklyn Bridge in numbers. So it was estimated that it would take 5 years to build the bridge, and it ended up taking 14 years. It was estimated that it would cost $5 million, and it ended up costing $15 million. And don't ask me how much that is in today's money because I'm terrible at doing those kinds of conversions. There were, let's see, what's my next number? The bridge is, I don't know what the 6 is. I must have accidentally deleted that. The bridge is 5,989 feet long, which is approximately 1.1 miles or 1.8 kilometers. It took 600 workers to build the bridge, 6,740 tons of material. The bridge is held up by 4 main cables and 21,000 smaller wires. Approximately 20 people died during that 14-year span of building the bridge. And the distance from the bridge to the water is 135 feet. Now, next slide. Now, the Brooklyn Bridge has undergone a number of revisions, as you can imagine, to keep pace with changes in transportation. And it is repaired, of course, as needed. Eventually, of course, the cable tracks were removed. Now it is, a car and pedestrian bridge. But it is still essentially the same beautiful and iconic structure that it was when it opened in 1883. And it still invokes this sense of admiration and wonder when visitors see it in person. It has been, I'm sure you know, a feature in movies and TV shows. As I mentioned at the beginning, it is a popular place for wedding proposals, wedding photos, other photos. It's definitely one of those photo ops. If you visit New York, you'll see people posing on the bridge to have their photo taken. And in 2017, the U.S. Department of the Interior applied for the bridge to be placed on the UNESCO list of World Heritage Sites. But as of this date, it has not made it onto the list, but the application